Hello everyone. In this visualization, we are going to draw a displacement vector. So how do we draw a displacement vector? Draw an arrow from the position where the object is located to where it would be located at next or another instant of time. So it is drawn using an arrow. The length of the arrow carries the information of how much the object moved, and the direction is given by the head of the arrow. Now in this simulation, we are going to consider one-dimensional motion. That too, the object moves only in one direction. That is, it does not turn around. So all the discussion would be for such a kind of motion. And for such a one-dimensional motion where the object is moving only in one direction, the length of the arrow, that is the magnitude of this displacement vector, is known as distance. Let's visualize the displacement vector in this graphical window. So we have this one-dimensional axis system, and let us plate of the object at about 20 plus meters on the right side of the axis system. And let us visualize the motion first. So this is how the object would move as a function of time. So the time can take values from 0 to 37.5 seconds, and the object would move from somewhere here all the way to right and out of the window. So first let us draw the position vectors at first instant of time, and this slider over here can select that. So the at first instant of time, that is 3.98 seconds, the object is at 31.84 meters. It is somewhere here, and this is the position vector for the first instance of time. And the second instant of time should be larger than 3.98. So let us put it a little away from that. So this is the second instance of time, that is 17.19 seconds. The object would be at 63.16 meters. So this is the position vector for second instance of time. So for the clarity, I have shifted both the position vectors upwards. Otherwise, they would be drawn on this central line. Now let us put the displacement vector. So this is the displacement vector, the arrow in black color, whose length is 31.32 meters, and it is pointing towards the right. So this arrow tells us that the object moved from this point to this point from first instance of time, that is 3.98 seconds to 17.19 seconds. Now it can be any other time. It is somewhere here, and the initial time remained same, the second time changed, so hence the position changed. So the displacement vector has also changed. So let us put the particle on the left side and see how the displacement vector and position vectors look. So now the object is here. So at t equal to 0, the object is at minus 22.40 meters. So let us put the position vector for that. So at t equal to 0, the position vector is this. So the blue color indicates that the particle is located on the negative side of the reference axis at minus 22.40. Let us select another time, little towards the left. Now at the second instance of time, that is 6.6 seconds, the object would be at minus 6.63 meters. This is this small arrow. And how does the displacement vector look? Let us draw it. So this is the displacement vector. Remember, the object is moving towards the right. Hence, the displacement vector would point towards right because the motion is happening in this direction. The length of arrow would tell that it has moved this much distance, that is 15.77 meters. So as we can see, 15.77 is obtained from minus 6.63 minus 22.40. And this delta 21, which is indicated here, is known as distance for any other instant of time. You can see at this, the object is on the left side, minus 22.4, and at 36.96 seconds, the object would be at 65.25 meters. Hence, the distance would be 87.65 meters, and it is moving towards the right. You can take another position. So the position vector for time t2 changes, and So the displacement vector also changes. So that's all for the displacement vector. Thank you for watching this video.